So you want infinite energy. The laws of physics say that's not possible, but we can get pretty close using nuclear fusion. The problem is, it's really hard to control, and yet we try. Before I explain how we try nuclear fusion, I should explain why we want it. It turns out that, because of Einstein's mass energy equivalence, if you shove two hydrogen-like atoms together hard enough, they combine to form a helium atom, a neutron, and tons of energy left over. And we can take that energy and convert it into electricity. This process is super efficient, and the only fuel it requires is atoms like hydrogen. But guess what? We have plenty of that. After all, water is made of hydrogen and oxygen. The trouble is, it takes a lot of pressure to keep hydrogen fusing, and we haven't cracked the code on sustained fusion yet. But one of the best guesses for how we might do that is with a machine called a tokamak. The goal of a tokamak is to convert the hydrogen to plasma and then contain it while it's heated up to hundreds of millions of degrees. By keeping it contained and increasing the pressure rises, with the idea being that if you get it hot enough, it'll start fusing. The question is, how do you confine it? Magnetic fields, of course. So there are three magnetic fields involved in a tokamak. The first is the main magnetic field, which gets its shape from the donut-like shape of the reactor. This is the toroidal magnetic field, and it runs in a circle through the meat of the donut. This way, moving charged particles will move along in a circle rather than just moving in straight lines. The next magnetic field is actually an induced magnetic field. By pulsing a large magnet inside the donut hole, the plasma starts to pick up a current that flows around the donut. And as current flow induces a magnetic field, the plasma itself creates a magnetic field that guides itself. The magnetic field loops around the plasma. This magnetic field, combined with the toroidal magnetic field, creates a helical magnetic field, causing the plasma to spiral as it goes around the donut. As an aside, this magnet is also what heats the plasma up initially. Higher current flow means higher temperature. Now, the reason why they want the spiral is because the changing strength of the toroidal field from outside to inside would inevitably cause a drift of the plasma to the outside of the donut, eventually causing it to hit the edge. So by spiraling the plasma, it continually drifts in, then out, mitigating this issue. The final magnetic field is an external vertical magnetic field. This magnetic field is just used to place the plasma ring inside the whole machine appropriately. Now, once you're ready to go, you heat up your plasma and off you go. To go past the upper limit temperature from the central magnet, microwaves bombard the plasma from the outside, increasing the temperature even more. And if you designed your tokamak well, you can heat it up so much and confine it so tightly within the magnetic fields that it ignites, keeping itself hot while undergoing fusion. We're not there yet, of course, but ITER will be returning on soon, and if we're lucky, we'll see ignition. Is because the changing strength of the toroidal, not quite hydrogen, but close enough, together hardly is hydrogen, a special. The pressure rises, with the idea being is because the changing strength of the. Before I explain how we try nuclear fusion,